So now we'll discuss the transformation of inertia matrix due to rotation of coordinate system. Suppose this blue x, y, z is a body fixed coordinate system. Now we give this blue x, y, z a rotation so that it becomes green x tilde, y tilde, z tilde. Both of these axis systems are body fixed and they are having their origin at the center of mass. So angle between x tilde and x is alpha x, angle between x tilde and y is alpha y, and angle between x tilde and z is alpha z. Angle between y tilde and x is beta x. Angle between y tilde and y is beta y, and angle between y tilde and z is beta z. Similarly, angle between z tilde and x is gamma x, angle between z tilde and y is gamma y, and angle between z tilde and z is gamma z. So we know that we already know how the components of a vector transform due to rotation. So the angular momentum vector in the new tilde, x tilde, y tilde, z tilde coordinate system will become this, which is the transformation matrix and the multiplied by the components of H in the blue xyz coordinate system, where T is the transformation matrix. So you know that this T can be expressed as L of x tilde, M of x tilde, N of x tilde, that is this. And what is the meaning of L x tilde? That means cos of the angle between x tilde and x. What is M of x tilde? M of x tilde means the cos of angle between x tilde and y. What is N x tilde means? The cos of the angle between x tilde and z. Similarly, L y tilde means cos of angle between y tilde and x. Cos of angle between y tilde and y. Cos of angle between y tilde, this should be z. Cos of angle between y tilde and z. Sorry, cos of angle between y tilde and z. And this is cos of angle between z tilde and x, cos of angle between z tilde and y, cos of angle between z tilde and z. So this is cos of angle between y tilde and z. So now here we know that H tilde, if we put, so starting from here we know that H tilde is equal to T into H and omega tilde equal to T into omega. So H tilde equal to T into I into omega, and that is again T into I into T transpose into omega, because omega is T inverse omega tilde, that is T transpose omega tilde. So now if we call this as I tilde, then H tilde is I tilde into omega, where I tilde is T I T transpose. Now you know that the rotation matrix is the transpose of the transformation matrix. So this can also be written as R transpose I R. So now if you just expand this, then you get this as your I tilde, this as T I and T transpose. Note that this row has become this column, this row has become this column, and this row has become this. So from here, if you want to find out I after this matrix multiplication, if you want to find out I x tilde, then I x tilde will be this first row, first column, first row, second column, first row, third column. So after multiplication of these two matrices, we know what will be the resulting first row, and the resulting first row when goes through this, you get this. So this is this into this into this. So this is I x tilde x tilde. If you are not comfortable with this, you can perform the full matrix multiplication and get I x tilde x tilde. So now if you perform this actual multiplication, then this becomes first row, first column. This is the first row, second column. This is the first row, third column. This is this into this into this, and this into this. And that post multiplied by this. So this is the final result. So I x tilde becomes this. So now if you arrange it, then this is this. Okay. Similarly, I x tilde y tilde will be this. So this into this into this into this. So we get the first row, and you go through the second column. So you get this term. So I x tilde y tilde is this, and if you arrange this, it becomes something like this. So these are the transformation relations. That means if you know Ixx, Iyy, Izz, Ixx, Ixy, Iyz, Izx, then you can get I x tilde, I x tilde y tilde, and all other in totality 9 terms of the new transformation matrix, the new inertia matrix, that is this one. Okay. So now what is principal moment of inertia? So we know that the new inertia, that is new inertia in the x tilde, y tilde, z tilde system, is related to the old inertia matrix by this relation. So this can be written as, this can be post multiplied by T, and since T transpose is T inverse, this becomes identity matrix. This becomes identity matrix. So this is IT. So Ti is IT. Now suppose, is it possible to get this I tilde as a diagonal matrix? So this is what we have done. This is the left hand side, and here this is the right hand side. Again, if you suppose you take this, so this into this into, so you are now multiplying. So if you now suppose I take this column out of this, so that will give me my this row into this column, this row into this column, this row into this column. That means the first column of the resulting matrix. This first row, first column, second row, first column, third row, first column will give me the first column. And what is the first column from here? This into this into second row, this into this third row. So this is what we get if we want to find out the first column from left hand side and right hand side. So this is what we get. Now see here, this can be written as this, where lambda is equal to I1. So this, you know, this is an eigenvalue problem, and if you find out the eigenvalues, then you get the principal inertia values. Or what you can do, you can just subtract the right hand, just take an identity matrix of 3 by 3 size and subtract from the left hand side. So you get this into lmn equal to 0, and that means you get this. So for non-trivial solution, the right hand side is 0. If you want to get a non-zero solution of this, then this matrix has to be singular. So from singular means determinant equal to 0. So determinant of this is equal to 0. So you get a cubic equation in lambda. You solve the cubic equation and you get 3 values of lambda, and those 3 values are I1, I2 and I3. Now what is an inertia ellipsoid? So from this transformation relation, so for Ixx, so this is the transformation relation Ix tilde x tilde with respect to xx, yy and zz, xy, yz and zx. So starting from this transformation relation, if you divide the left hand side by this term itself, then you get this, 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 this. Now if you replace this by u, this by v and this by w, you get an equation like this, where u is lx by I lx tilde by ix tilde x tilde root over v equal to mx tilde by root over ix tilde x tilde, and w is equal to this. Now if you assume that this x, y, z, not the x tilde, y tilde, z tilde, this x tilde, y tilde, z tilde coordinate system is a principal coordinate system. That means here the product terms are zeros. Then here you get an equation like this, or an equation like this, or an equation like this. That means if your x, y, z are the principal, if your x, y, z are the principal axis, then you get an ellipsoid if you plot this equation. So this axis is u axis, and this u axis is nothing but this, and v axis is nothing but this, and nothing but this. That means u, v, w are proportional to the direction cosines of x tilde. Now this is called the inertia ellipsoid. That means once you know the principal moment of inertias, then what you can do, you can find out what is 1 by root over ixx, 1 by root over iyy and 1 by root over izz, and with that as a value you get the 3 axis and draw the ellipsoid. And any point on the ellipsoid, suppose your u is this much and v is this much, then w has to be this much, because u square plus v square plus w square is always this, or lx square plus mx square plus nx square equal to 1. So this point will give you, if you know now the u and v, this point will give you ix tilde x tilde. So let us stop here, and in the next class we will see parallel shift of coordinates.
So here actually inertia ellipsoid. So one student asked me that what can we do with the inertia ellipsoid. That means if you know the principal moments of inertia like Ixx, Iyy, and Izz, you can draw this ellipsoid, and at any take any point on this ellipsoid. For that point, O to P will give you O to P, 1 by O to P will give you the Ixx value about that direction, and that direction is given by this UVW. So that means that direction is given by UVW. So that means here, so suppose you take this point. From this point you drop a perpendicular on the UV plane and get V and W. So UV and W will give you the direction cosines of the direction about which you are getting this I x tilde x tilde. That means this I this OP1 by OP, this I x tilde will be for the direction cosines given by this UV W. So that is the use of inertia ellipsoid. And here also I have changed the derivation. So in my previous derivation, I took this r from the center of mass to the origin of the new coordinate system. But I think it is always better to take, and in all books it is taken from the origin of the new coordinate system to the origin of the to the center of mass. So I should be here to r should be from here to here and not from here to here. And in my previous derivation I took r from here to here. So this is the small change which you have to make. I have made this change, so everything else remains same. So now if you see, look at the projections. So if you look from here, if you look from here, if you look from here, so that your x is coming towards you from the plane of the screen, then this is your xyz. This x is just x is here, this is y and z, and this is y dashed and z dashed. So this is y dashed and z dashed. So x dashed is coming towards you, and this is the infinitesimal mass, and this is actually ry, and this is rz. This is ry and this is rz. And the dx is the perpendicular distance between x and x dashed. X dashed is coming out of this plane. X dashed is also coming out of this plane, and dx is the perpendicular distance between them, and dx is nothing but ry square plus rz square. So similarly, if you take projection in the xy plane, this is a projection in the xy plane. That means now z is coming towards you. So if your this z comes towards you, this is x, this is y, this is x, this is y, and this is x dashed and this is y dashed. Again rx is this and ry is this. And if you make y perpendicular to the plane of the paper, if you make y perpendicular to the plane of the paper, if you make y perpendicular to the plane of the paper, then x and z you will be able to see. So this is x dashed, z dashed, and this is x z. So this is rx and this is ry. So now this, in this relation, x dashed means from here to here, from here to here, this is x dashed. Also also from here, also from here to here. This is also x dashed along x dashed here to here. So x dashed is equal to x plus rx. Similarly, y dashed equal to y plus rx and z dashed equal to z plus rz. So now I x dashed equal to this from definition. Now in place of y dashed we put y plus ry, and in z dashed z plus rz. So now the derivation is very similar. So now the final relation is also same, but only r is now measured from the x dashed, y dashed, z dashed origin to the center of mass. Everything else is same. And in the product of inertia part also, you put plus signs. In the previous one, negative signs we used here. So the relationships remain same. So here you have to remember that Rx is measured from x dashed to x, and Ry is measured from y dash to y, and Rz is measured from z dash to z. So and xyz is through the center of mass. So this is a small correction, and in the example which we will be discussing next, you will find the use of this correction. So thank you.